Did you know that you could buy a piece of moon land for just $35 per acre? It sounds like a steal, but it is real. On August 23, 2023, India landed its Chandrayaan-3 spacecraft on the moon for the first time. This national achievement fired up folks in India, leaving them to go wild buying up plots of land on the moon. An issue arises here. No national or international law actually allows anyone to own plots in space. So, those lunar certificates, well, they're just fancy papers. As you can imagine, though, these certificates could cause some real trouble when colonizing the moon in the future. What if people started claiming pieces of land that their ancestors paid for? Some kind of regulation is needed, or we might end up in some serious drama. This lunar land rush is just a small hiccup on our epic journey to the stars. As humanity starts to settle new worlds, we'll discover that building a true space civilization is incredibly complex. Think about the governments, communications, and even finance. How could we possibly build something like that on another planet in a reasonable time, say by 2730? Interplanetary Communication. Picture this. It's 2730 and future spaceship pilots are endlessly scrolling through videos and online content as they navigate the cosmos. How is it possible? The internet, as we know it, is simply impossible in space. Trust me though, there might be a solution. On Earth, a bit of information can zip around the globe 7 times per second thanks to transcontinental fiber optic cables that carry signals at light speed. This isn't just about comfortably watching cool YouTube videos like this one. This speedy communication is essential for our civilization's leaders to make timely and informed global decisions. But you can't exactly string fiber optic cables between constantly moving planets. In our solar system, NASA uses massive 70-meter radio antennas scattered across the globe to communicate with its spacecraft. These antennas can boost transmissions from Earth by 100 million times. Yet, due to signal scattering, up to 20% of the signal doesn't even reach the edges of our solar system. This can easily blur the line between a friendly hello and an accidental insult. In space, Earth's internet would be a no-go with such massive data loss. As humanity ventures further into the stars, we'll need to reimagine communication entirely. Interplanetary network. Perhaps we could think of building a network with Mars as a base. If we manage to put relay satellites and a signal booster into orbit, we could aim for a connection to Earth at 1 megabit per second. Yeah, that's like 100 times slower than your standard Earth internet. Plus, depending on how far Mars is from us at the time, the signal delay could be anywhere from 3 to 22 minutes. Imagine trying to have a video call with awkward pauses. Yikes! And it gets worse the farther you go out. Messages to Jupiter's moons could take up to an hour. Trying to flirt with someone on Neptune? Well, better make sure your message is crystal clear, because they'll have a good 4 hours to mull over what you said. This delay would represent a huge problem if we ever came in contact with aliens. Think about this. The closest exoplanet is 4.24 light years away from us in the Proxima Centauri system. That's like way out there. We need enormous radio dishes, like bigger than Earth itself, to even think about sending a text message. And of course, assuming that aliens don't ghost you, it would take the same time to get an answer. So yeah, with today's tech, our dreams of chatting with distant star colonies are pretty much on ice. It's a bit of a buzzkill, I know, but hey, at least within our solar system, we might manage a decent civilization, even if we have to put up with super annoying delays in communication. It's like living in a slower version of the Roman Empire, where news took ages to travel between cities. By the way, how often do you think about the Roman Empire? Interstellar Government. Speaking of empires, founding an interstellar government poses a host of complex challenges, not least of which involves the diversity of forms of life that could potentially exist on other planets. Imagine encountering intelligent aliens. How would they fit into the political landscape? Would they have rights, representation? The sheer diversity of species and civilizations could make forming a cohesive government a daunting task. Politics in an interstellar government would likely need to be highly adaptive and inclusive, and we definitely need to start talking about it if we want to be ready for it by 2730. Systems of governance seen on Earth, like monarchies or republics, might not adequately address the complexities of interspecies diplomacy and governance. A monarchy, for instance, might struggle to represent diverse species equally, while a republic might face challenges in balancing the interests of vastly different civilizations. One potential approach could involve a federated system where different planetary systems retain a degree of autonomy while cooperating on larger-scale issues such as trade, defense against common threats, and cultural exchange. This could resemble a loose confederation where each member retains its unique identity while contributing to a broader collective. The differences between politics on Earth and in an interstellar government would be profound. On Earth, politics are often shaped by national borders, cultural identities, and historical conflicts. In contrast, an interstellar government would need to transcend these boundaries and address issues on a galactic scale. Issues like resource distribution, interspecies rights, and the regulation of advanced technologies. One major advantage of an interstellar government could be the opportunity for unprecedented collaboration and knowledge exchange among civilizations. Sharing scientific discoveries, cultural practices, and technological advancements could accelerate progress in ways unimaginable on Earth. However, this potential comes with significant risks, such as the possibility of cultural clashes, conflicts over resources, or unintended consequences from sharing advanced technologies. Moreover, the sheer distances involved in interstellar travel would necessitate innovative solutions for communication and decision-making. Governance structures would need to be flexible enough to adapt to the unique challenges posed by communication delays and the vastness of space. Ultimately, the path to forming an interstellar government would be fraught with uncertainties and complexities. It would require navigating uncharted territory both literally and metaphorically, and finding a balance between unity and diversity among the myriad civilizations that might make up such a government. The lessons learned from terrestrial politics would provide a foundation, but the challenges of governing across light years would require entirely new frameworks and approaches. Interstellar banks. Money and finance in such an interstellar government would be a whole new frontier. Traditional currencies like cash and credit cards might evolve into something entirely different. Perhaps a universal cryptocurrency that transcends planetary boundaries. This would facilitate trade and transactions between different species and civilizations, overcoming the logistical nightmare of converting currencies across different planets. Would it be possible to come up with such a system in the next 706 years? Who knows? Also, deciding who can afford to buy land on another planet raises complex ethical and legal questions. For instance, it is very hard to tell who will enforce property rights and resolve disputes between different species or factions. Establishing a banking system capable of operating across light years would be an enormous challenge. Banks would need to manage transactions with significant time delays due to the vast distances involved in interstellar travel. They would also need to secure financial data against threats that are literally out of this world, like cosmic radiation and advanced hacking techniques. Furthermore, the infrastructure required to support life on other planets is another significant hurdle. We need sustainable sources of food, water, and energy in environments vastly different from Earth. This includes developing technologies for terraforming or building self-sustaining habitats capable of supporting diverse species. Legal frameworks would also need to be developed to handle conflicts and disputes that arise in space. Who has jurisdiction over crimes committed in orbit or on another planet? How would laws be enforced when enforcement agencies could be light years away? Additionally, ethical considerations would be paramount. How do we ensure fair treatment and rights for all species, regardless of their level of technological advancement or cultural differences? Issues such as exploration, colonization, and the preservation of indigenous cultures would require careful consideration and regulation. In essence, while the prospect of an interstellar government holds immense promise for cooperation and progress, Achieving such a system would demand unprecedented levels of technological innovation, international collaboration, and ethical foresight. It would require humanity, and potentially other intelligent species, to transcend earthly boundaries and forge a new era of governance that reflects the vastness and diversity of the cosmos. Resources, mining, and colonization. Sustaining an interstellar population presents a colossal challenge, especially when considering the diversity of dietary needs and resource requirements among different species. On Earth alone, we already contend with the complexity of feeding a global population that includes omnivores, carnivores, vegetarians, and various dietary preferences. Scaling this up to an interstellar level introduces an entirely new dimension of complexity. One of the key strategies for sourcing resources could involve mining asteroids and comets. These celestial bodies are rich in minerals, water, and organic compounds, which could be crucial for sustaining life and supporting industry and space colonies. Mining operations on asteroids and comets would likely require advanced robotics and automated systems due to the inhospitable conditions in space. Another potential resource could be exoplanets that do not harbor intelligent life. Ethical considerations aside, these planets could provide raw materials, water, and potentially even agricultural land for sustaining interstellar populations. However, the logistics and ethical implications of exploiting other planets would need to be carefully considered, as it raises significant questions about environmental impact and interstellar diplomacy. Moreover, developing technologies for sustainable agriculture and resource recycling within space habitats would be essential. Closed-loop systems capable of efficiently recycling water, nutrients, and waste would reduce reliance on external resources and minimize the environmental footprint of interstellar settlements. In addition to physical resources, energy would be a critical consideration. Solar power, nuclear fusion, and potentially even harnessing energy from black holes or other exotic sources could provide the necessary energy for interstellar civilizations. However, developing and deploying such advanced energy technologies would require substantial scientific and engineering advancements. Technological advancements. The warp drive. Imagine if in the future, after the year 2730, humans and our extraterrestrial bodies team up to build the first warp drive. It's like a sci-fi dream come true, where we all put our heads together, Earth scientists, alien engineers, everyone, and start brainstorming in this massive cosmic think tank. Wait, you don't know what a warp drive is? Essentially, it is a theoretical technology that would allow spaceships to travel faster than the speed of light. It's like a super-fast engine that bends space around a spaceship, making it possible to reach far-off stars and galaxies in a relatively short time. The idea of a warp drive was popularized by a physicist named Miguel Alcubierre in 1994. He proposed a concept where a spaceship could create a sort of warp bubble around itself. This bubble would contract space in front of the ship and expand it behind, effectively moving the ship faster than light without violating the laws of physics, like Einstein's theory of relativity. Now, why is it so hard to make? Well, there are a few big challenges. First, we're still figuring out how to generate the incredible amounts of energy needed to power a warp drive. The energy requirements are way beyond anything we can produce with our current technology. Secondly, even if we could generate enough energy, we don't fully understand how to manipulate space-time in the precise way needed to create and control a warp bubble. It's like trying to bend a piece of paper without tearing it, except space-time is way more complicated. Lastly, building and testing a warp drive would require huge advancements in physics, engineering, and material science. As you can see, building a warp drive is not an easy task. But what if we got some help from our alien friends? Different civilizations, each with their own crazy tech and perspectives, could come together to crack the code of interstellar travel. Diplomats would be busy hammering out deals that make sure we would get along and share the resources needed for this wild ride. Meanwhile, up in space, our shipyards are buzzing with activity. Giant starships fueled by mind-blowing energies and filled with next-level navigation systems start taking shape. When the first warp-capable starship will finally launch, it will be like the biggest block party in the galaxy. We'll have got folks from Earth, Alpha Centauri, and probably a few places we've never heard of, all cheering on this historic moment. The crew, humans, aliens, you name it, will set off on a journey that's gonna rewrite the space travel rulebook. Out there, we're cruising through wormholes, hopping on cosmic highways, and chatting it up with civilizations that grew up under totally different skies. Every encounter teaches us something new about the universe and tightens the bonds between species. It's all about pushing boundaries, making friends with aliens, and proving that when we work together, there's no limit to what we can achieve. What if? But now let's pivot and take a hard look at the challenges that could derail the dream of an interstellar civilization. Sure, it's exhilarating to think about humans and extraterrestrial beings teaming up to explore the cosmos together. Yet the reality is sobering. We're still in our infancy when it comes to space exploration. While we've launched probes to neighboring planets and even ventured beyond our solar system's edge with missions like Voyager, the leap to establishing sustainable human colonies on distant planets or traveling between stars is monumental. We're talking about distances so vast that even our fastest spacecraft would take generations to reach the nearest star systems. The technological, logistical, and biological hurdles to overcome are immense. Then there's the Fermi paradox, a haunting question in the search for extraterrestrial intelligence. If advanced civilization exists elsewhere in the universe, why haven't we detected them? One unsettling possibility is that these civilizations might not be friendly or cooperative. They could view us as a threat, have inscrutable agendas, or simply exist beyond our current comprehension. The prospect of encountering such civilizations raises serious concerns about conflict, exploitation, or encountering moral and ethical dilemmas we are ill-prepared to handle. Anyway, let's say we found a planet populated with intelligent creatures and decided to land on it. What approaches could we use? There are valuable lessons to be learned from the methods used by historical explorers on Earth. These could guide us in navigating the challenges of exploring new worlds beyond our solar system. Firstly, similar to how historical explorers sent out scouts to gather information about new lands, modern robotic probes serve as our scouts in space. These probes conduct extensive surveys of the planet's surface, analyze its atmosphere, and gather critical data about potential hazards. This reconnaissance is essential for identifying safe landing sites and understanding the local environment before human missions commence. Mapping and cartography were crucial tools for early explorers navigating unfamiliar territories. Today, orbiters equipped with advanced imaging systems and aerial drones play a similar role in creating detailed maps and topographical surveys of planets. These maps provide valuable information for selecting optimal landing locations and identifying areas of scientific interest. Just as historical explorers relied on local guides or indigenous knowledge to navigate and survive in unfamiliar lands, robotic rovers act as our local guides on other planets. These rovers, equipped with sophisticated sensors and artificial intelligence, autonomously navigate and assess the terrain in real time. They provide critical data on soil composition, geological features, and potential hazards, ensuring safe and informed decision-making for human explorers. Survival strategies employed by historical explorers adapted to local environments are mirrored in the planning of initial habitats or stations on other planets. These habitats are equipped with life support systems and sustainable technologies that utilize local resources for water, oxygen generation, and food production. This reduces reliance on Earth for resupply missions and enhances the sustainability of long-duration missions. Anyway, even if we manage to navigate potential hostile encounters, the practical challenges of sustaining life beyond Earth are daunting. We would need advanced closed-loop systems for food, water, and oxygen that can function independently for generations. The risk of catastrophic failures, from technical malfunctions to resource depletion or environmental disasters, is ever present and could mean disaster for entire colonies. Moreover, as we explore and potentially colonize new worlds, we face profound ethical dilemmas. how do we ensure that our actions respect the rights and autonomy of any alien life we encounter? The temptation to exploit resources or alter ecosystems for our own gain could have devastating consequences, not just morally, but practically as well. You know, when we look at the challenges of interstellar exploration, it's easy to think it's impossible. But history has shown us time and again that if we strive to make something happen, it can indeed happen. Take the moon landing, for instance. In the 1960s, many thought landing humans on the moon was an impossible dream. Yet with the courage, will, and patience, NASA and its partners achieved the seemingly impossible on July 20th, 1969, when Neil Armstrong and Buzz Aldrin set foot on the lunar surface. Or consider the International Space Station, the ISS. Building and maintaining a habitable outpost in space involving multiple countries working together was a monumental task. It required decades of collaboration, technological innovation, and persistence. Today, the ISS stands as a symbol of what can be achieved when we have the courage to pursue ambitious goals in space exploration. Similarly, the Mars rovers, Spirit, Opportunity, and Curiosity have defied expectations by exploring the Martian surface for years, far exceeding their initial mission lifetimes. These robotic explorers continue to uncover new discoveries and pave the way for future human missions to Mars. So when we talk about building interstellar civilizations or achieving breakthroughs in space exploration, it may seem daunting. But history teaches us that with the courage to dream big, the will to overcome challenges, and the patience to see it through, humanity can turn the impossible into reality.